Hello BYW students, it's Mr. Sullivan. Today we are going to be doing lesson 9-2, Intro to Trigonometric Ratios. Today's learning target is I can apply trigonometric ratios by determining the proportions of my side lengths. 1 second. Okay, so what we're going to be doing today is learning the basics of trig, which is SOHCAHTOA. You might have heard that from students in the halls, I'm not sure. Trigonometry is the study of relationships of the sides and angles of triangles. The ratios of these sides play a crucial role in trigonometry. Trigonometric ratios are the ratios of the sides of a right triangle defined in connection with an acute angle in the triangle. This angle is always going to be referred to as the reference angle. So we're going to be looking at reference angles today. Okay? When working with the acute angle within a triangle, we identify the sides of the triangle based on its relationship to that marked angle or our reference angle. And they've always followed the same pattern. The side across from your right angle will be your hypotenuse, which we'll say as H when labeling our image. The side across from the reference angle is your opposite side. We're going to say O when we label our image. And then the side next to the marked angle, which is not the hypotenuse, is your adjacent. And I save our adjacent for last because it's always the hardest one to identify. Okay. What we're going to be doing right now is labeling the sides as hypotenuse, opposite, and adjacent with respect to the marked reference angle. The reference angle is never going to be your right angle. Your reference angle will always be marked like this. So in this image, angle F is my reference angle. So the first side we're going to identify is our hypotenuse, which is the side across from our right angle. So I'm going to draw an arrow across from D and get this as my hypotenuse. FE is my hypotenuse. Now we're going to label our opposite. So we put our pen on F, go across, and boom, we hit DE, which is our opposite. And then last but not least, FD has to be our adjacent because that's the side next to our reference angle. Okay? Now let's do this image. In this image, what is my reference angle? Very good, R is my reference angle. The first side I'm going to identify is my hypotenuse, which is across my right angle. The side across my right angle is PR. So PR is your hypotenuse. Now we're going to identify the opposite side, which is across from your reference angle. So in this case, my opposite side is QP. Now we're going to identify our adjacent, which last but not least is QR. Okay? So now trigonometry allows us to link angle size and right triangles to side proportionality. The converse is also true. If we know the ratio of two sides of a right triangle, then there exists one reference angle that has that ratio. Trigonometry connects angle measure to side measure, thus it's a very powerful piece of math. These three ratios that we have established have names: sine, cosine, and tangent, and they all play a role in various areas of math, and they're on your calculator. Okay? So now what we're going to do is we're going to actually go over what these functions are. And by the way, instead of using x, we're going to be using this Greek letter, theta, which is used as your default angle for trig function. It's a Greek letter, theta. So sine of theta is always going to be opposite over hypotenuse. It's always going to be your opposite side over your hypotenuse. Which you can write as O over H. So in this image, my opposite is BC and my hypotenuse is AB. So I can say BC over AB as well for this image. Cosine of theta is my adjacent over hypotenuse. And this is just facts. You have to memorize them. You can also just say A over H. And in this case, my adjacent is AC and my hypotenuse is AB. Now tangent of theta is opposite over adjacent. And in this case, your opposite is BC, and my adjacent is AC. And you also can say O over A. Okay, so now you're probably wondering, how do I memorize those? And it's actually pretty straightforward, I promise you. There's this trick called SOHCAHTOA. So, ka, toa. And if you think about it, it actually makes sense. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So, ka, toa. Okay? So that is a acronym or a mnemonic device that you have to memorize, okay? So what we're going to do is we're actually going to have that SOHCAHTOA labeled on every single page. Well, for every single problem. So for this problem, I'm going to put it right here. And this problem as well, I'm going to put it right here. Okay? So label the sides of the triangle with respect to the marked reference angle as height, up, and adjacent. So there's going to be two sets of problems going on in each one. The first one, we're dealing with A as our reference angle, and in the second set, we're dealing with B as our reference angle, and that's going to be the same for both problems. So the first set of questions we want to deal with is with A as our reference angle. So let's look at A as our reference angle. When looking at this problem, the first side I want to identify is my hypotenuse, which is across from my right angle. So in this case, my hypotenuse is 13. Now I want to label my opposite side, which is across from my reference angle. In this case, my opposite side across from my reference angle is 12. And then last but not least, we label our adjacent, which must be a 5. So we know sine of A is opposite over hypotenuse. So we know it's opposite over hypotenuse. And in this case, our opposite is 12. And our hypotenuse is 13. So we can say sine of A is 12 over 13. Now we want to do cosine of A. We know cosine of A is adjacent over hypotenuse. I'm going to do A over H. And in this case, my adjacent is 5. And my hypotenuse is 13. And that's my final answer. Now, tangent of A is opposite over adjacent. And my opposite side is 12, while my adjacent is 5. So my final answer is 12 over 5. Now what I'm going to do is I'm going to erase my markings because now we're dealing with a different reference angle. If you look for this set of problems now, we're dealing with B as our reference angle. So we're going to be looking at B as our reference angle. So the first side I want to label is my hypotenuse, and that's across my right angle. My hypotenuse is 13. Now I want to label my opposite, which is across my reference angle. Across my reference angle is 5, so 5 is my opposite, which means last but not least, 12 has to be my adjacent, because it's the side next to my reference angle. Okay, now we want to do sine of B. Again, we know sine is opposite over hypotenuse, and in this case, our opposite is 5, and our hypotenuse is 13. Now, cosine of B. Well, cosine of B is adjacent over hypotenuse. And our adjacent is 12, while our hypotenuse is 13. And then tangent of B is opposite over adjacent. And in this image, our opposite is 5, and our adjacent is 12. So what we're doing is we're finding the proportions for that reference angle. Now let's go on to this next set of problems. So using the picture below, identify the following trig ratios. In the first set of problems, our reference angle is angle D. So we're going to be using D as our reference angle. So the first thing I'm going to do is I'm going to identify my hypotenuse, which is the side across my right angle. The side across my right angle is a 2. So 2 is my hypotenuse. Now we're going to label our opposite, which is the side across my reference angle. So our opposite is radical 3. Now we want to label our adjacent, which is a 1. So the first thing we want to do is we want to do sine of D. Sine of D, we said, is opposite over hypotenuse. So I want to label my opposite. Say my opposite. My opposite is a radical 3. my hypotenuse is 2. So I get radical 3 over 2 as my final answer. Cosine of d is adjacent over hypotenuse. And my adjacent side is a 1, and my hypotenuse is a 2. So I get 1 over 2 as my final answer. Now I want to do tan of d. And tan of d is opposite over adjacent. So my opposite side is a radical 3. My adjacent's a 1, which simplifies to radical 3. And that's your final answer. Now we're going to do the E as our reference angle, E as our reference angle. So what I'm going to do is I'm going to erase my image basically because we're changing it up a little. And E is our reference angle. The first thing I do is I label my hypotenuse. My hypotenuse is 2. Very good, because the side across my right angle. Now we need to label our opposite. Across my reference angle is my 1. And then last but not least is my adjacent, which is square root 3. So now what I want to do is I want to find the sine of E, but we know sine is opposite over hypotenuse, and our opposite side is 1, and our hypotenuse is 2. So sine of E is 1/2. Now we want to find cosine of E. Cosine of E is adjacent over hypotenuse. So we get a radical 3 over 2. And then last but not least, we do tangent of E, which is opposite over adjacent. And that gives us 1 over radical 3. But do we like that radical 3 in the denominator? Very good, we don't. So we're going to rationalize it. So we know 1 over radical 3, if we want to simplify it, we multiply our numerator by rad 3 and our denominator by rad 3. What's 1 times radical 3? Very good, it's radical 3. And what's radical 3 times 3? It's 3. So I can say tangent of E is radical 3 over 3 for this image. And that's it for today. Don't forget to complete your delta math. If you have any questions, email myself or Ms. Calarunto. Have a great day, ladies.